In May 1950, Indianapolis Motor Speedway, Bill Holland crosses the finish line averaging 121 miles per hour, powered by a four-cylinder engine designed 17 years earlier. That same basic design would win the 527 more times. No V8, no V12. Just four cylinders and one brilliant engineering principle that every competitor kept trying to copy but never quite mastered. What made the Offenhauser engine so dominant for so long? And why couldn't the world's biggest manufacturers ever truly beat it? Here's how it happened. May 30th, 1976. Indianapolis Motor Speedway. Johnny Rutherford wins the race. Average speed 148 miles per hour. It's the last time an Offenhauser engine will win Indianapolis, but what a way to go out. 43 years after the basic design first appeared. 43 years of evolution, refinement, and absolute dominance built on principles that stayed remarkably consistent. Here's what makes that victory remarkable. By 1976, the Offenhauser was competing against purpose-built Formula One engines, turbocharged power plants backed by international manufacturers, and cutting-edge metallurgy that would have seemed like science fiction in the 1930s. Yet this American four-cylinder, born in the depths of the Depression, remained competitive at the highest level of oval track racing. The numbers tell the story. Between 1935 and 1976, Offenhauser engines won Indianapolis 27 times. They powered winners through 6 decades of automotive evolution, from the era of bias ply tires and beam axles to wings, slicks, and ground effects. No other engine in motorsport history can claim that kind of sustained dominance at a single venue. But the Offy wasn't just successful, it was ubiquitous. In some years during the 1950s and 60s, 90% or more of the Indianapolis starting grid ran Offenhauser power. If you wanted to win at Indy, you ran an Offy. It became almost definitional, the sound and fury of Memorial Day weekend inextricably linked to that four-cylinder howl. What made this possible wasn't just good fortune or racing politics. The Offenhauser succeeded because of specific, deliberate engineering choices that proved almost perfectly matched to the demands of oval track racing. Choices about breathing, about thermal management, about power delivery. Choices that seemed conservative when first made, but turned out to be exactly right for a racing format that would remain remarkably stable for decades. The engine's architect, Fred Offenhauser, understood something fundamental. Indianapolis wasn't about peak horsepower or revolutionary technology. It was about surviving 500 miles at sustained high RPM while maintaining precise fuel consumption and mechanical reliability. The Offy delivered all three better than anything else year after year. By the mid-1950s, when the Offy's dominance was absolute, mechanics could rebuild these engines almost by feel. Parts were standardized, techniques were proven, and the engineering was mature enough that incremental improvements came from refinement rather than reinvention. This stability became its own advantage. While competitors constantly chased new technologies, Offy runners perfected what already worked. But there was another factor, one less celebrated but equally important. The Offenhauser was an independent engine. It wasn't tied to factory politics or corporate priorities. Small shops could buy an Offy, campaign it successfully, and compete against the biggest names in racing. This democratization of Indianapolis power created a deep knowledge base and ensured constant development pressure. Yet the question remains, how did a design finalized before World War II stay competitive into the mid-70s? What core engineering principle allowed it to evolve and adapt while maintaining its fundamental architecture? To understand how this engine became possible, we need to go back to the world that created it, to the boardrooms and workshops of 1920s Los Angeles, where racing ambition collided with Depression-era economics. The year was 1923. Harry Miller, already legendary among racing circles, was building engines in Los Angeles that rewrote the rules of American motorsport. Miller's straight-eight power plants dominated Indianapolis throughout the 20s, combining sophisticated double overhead cam valve gear with advanced metallurgy. These were expensive, exotic machines, the Formula One engines of their era. Miller's chief engineer was Fred Offenhauser, a quiet, methodical German immigrant who understood both the elegance of Miller's designs and their fundamental limitation. They were too complex and too expensive for most racing teams to maintain or afford. While Miller chased technical perfection, Offenhauser thought about practical sustainability. The late 20s marked the peak of Miller's dominance at Indianapolis. His engines were engineering marvels, but the company's business model was fragile. Each engine required extensive custom fabrication. Support was centralized. When something broke, you needed Miller's shop to fix it. This worked during boom times, but storm clouds were gathering. October 1929, the stock market crashed. Suddenly, wealthy sportsmen who'd funded Miller's racing operations weren't writing checks anymore. Racing teams that could afford exotic 8-cylinder engines in 1928 were struggling to pay mechanics in 1930. The economics of American motorsport changed overnight. Harry Miller attempted to adapt. In 1930, he designed a 4-cylinder engine, essentially one bank of his straight 8, hoping to offer a more affordable option. It showed promise, but never fully materialized as a commercial product. Miller's company was drowning in debt, battered by the Depression and by Harry's own financial mismanagement. Fred Offenhauser watched this unfold with the calm calculation of an engineer who'd seen it coming. In 1933, as Miller's company collapsed into receivership, Offenhauser and business partner Dale Drake purchased the rights to Miller's 4-cylinder design. They paid just $35,000 for equipment and patterns that represented decades of Miller's development work. This wasn't just opportunism. Offenhauser had a vision. He understood that Indianapolis needed an engine that combined Miller's technical sophistication with Depression-era economics. Reliability over peak performance, maintainability over exotic materials, evolutionary potential over revolutionary design. The timing was perfect. Indianapolis racing in the mid-30s was fragmenting. The AAA contest board was revising rules to reduce costs and increase car counts. Engine displacement limits were dropping. The era of wealthy gentleman racers was ending, replaced by working-class mechanics and drivers who needed equipment they could afford and fix themselves. Offenhauser saw opportunity in simplification. Take Miller's basic architecture, his double overhead cam layout and hemispherical combustion chambers, but engineer it for durability and ease of maintenance. Reduce cylinder count from 8 to 4. Cutting parts count and complexity. Design everything for standardization and availability. The engineering philosophy was pragmatic. Miller had chased the bleeding edge. Offenhauser would chase the optimal edge, the point where performance met reliability and cost. This wasn't about building the fastest engine for one race. It was about building an engine that could win consistently, season after season, in the hands of teams without unlimited budgets. Fred Offenhauser and Dale Drake established their shop in Los Angeles, inheriting Miller's talented machinists and his reputation for precision work. They refined the 4-cylinder design throughout 1933 and 34, testing, measuring, learning what worked under sustained racing conditions. By 1935, they were ready. The Offenhauser engine, or Offy, as it would become universally known, made its Indianapolis debut. The basic architecture was pure Miller. Dual overhead cams, 4 valves per cylinder, hemispherical combustion chambers. But the execution was pure Offenhauser, robust, maintainable, and designed for long-term development rather than short-term glory. What Offenhauser and Drake couldn't have known was that they'd created something far more significant than a racing engine. They'd created a platform, one perfectly suited to evolve with American oval track racing for the next 4 decades. The secret to that longevity wasn't in what the engine did in 1935, it was in what the design would allow it to become. The Offenhauser's architecture was deceptively straightforward, a 4-cylinder inline engine with dual overhead camshafts and 4 valves per cylinder. But the genius was in how these elements worked together, creating an engine that breathed better, ran cooler, and produced more usable power than anything else in its class. Start with the cylinder head. The Offy used hemispherical combustion chambers with intake and exhaust valves arranged in a splayed configuration across the dome. This geometry allowed larger valves than a conventional flathead design, improving volumetric efficiency. Think of it like lungs. The more surface area you have for air exchange, the more oxygen you can process. The Offy's heads gave it bigger lungs than the competition. The dual overhead camshaft setup meant direct actuation of each valve. No push rods, no rocker arms introducing flex or friction into the valve train. At high RPM, this directness was crucial. When an Offy was spinning at 6,000 RPM, each valve was opening and closing 100 times per second. Any slop or flex in the actuation system would mean lost power and potential mechanical failure. The Offy's rigid direct valve actuation meant it could reliably sustain high RPM for the entire 500 miles. Offenhauser's team designed the engine for thermal stability. Indianapolis meant sustained full throttle operation, sometimes for minutes at a time. Most engines couldn't handle that heat load without detonation or mechanical distress. The Offy's combustion chamber shape promoted efficient burning and even heat distribution. The hemispherical design put the spark plug at the center of the chamber, allowing flame propagation to reach all areas of the mixture quickly and uniformly. The engine's stroke-to-bore ratio was carefully optimized for oval track racing. According to period tests, the Offy produced peak torque in a relatively narrow RPM band, but that band coincided perfectly with the sustained speeds at Indianapolis. This wasn't an engine designed for flexibility or street manners. It was designed to live at 5,000 to 6,000 RPM hour after hour without drama. Metallurgy mattered enormously. Offenhauser and Drake used aluminum extensively for the cylinder head and crankcase, saving weight while improving heat dissipation. The crankshaft was forged steel, balanced to tolerances that seemed excessive in the 30s, but proved essential for longevity. Connecting rods were machined from solid billets, not cast, giving them superior fatigue resistance under sustained loading. The Offy's oiling system was overbuilt by design. Full-pressure lubrication to all main bearings and connecting rod journals with multiple oil passages ensuring adequate flow even under high cornering loads. This attention to lubrication meant the engine could survive the sustained high-G loading of oval track racing, where centrifugal forces tried to starve bearings of oil on every turn. One critical detail often overlooked: the Offy was designed from the beginning for easy disassembly and inspection. Offenhauser understood that racing engines needed frequent rebuilds. The cylinder head came off with straightforward bolt patterns. The crankcase split horizontally for easy crank and rod inspection. Everything was designed so a competent mechanic could perform a complete teardown and rebuild in a single weekend. This maintainability created a virtuous cycle. The more Offys that raced, the more mechanics learned about them. Knowledge accumulated across the racing community. Best practices for tuning, building, and maintaining these engines became common wisdom. By the late 40s, you could find someone who knew Offys at virtually any oval track in America. The engine's modular nature allowed continuous evolution. Displacement increased from 220 cubic inches in the mid-30s to 427 cubic inches by the 60s, all within the same basic architecture. Fuel injection replaced carburetors. Supercharging became standard. Metallurgy improved dramatically, yet the fundamental design, those hemispherical chambers and dual overhead cams, remained constant. What made the Offy special wasn't any single revolutionary feature. It was the synthesis, the way every element supported sustained high RPM operation under racing conditions. It was an engine optimized for one specific task and refined obsessively to do that task better than anything else. But every revolution has its breaking point, and this one was about to face its own, not from mechanical failure, but from forces far beyond the engineering shop. May 1964, Indianapolis Motor Speedway. A.J. Foyt wins driving an Offenhauser-powered Watson Roadster, averaging 147 miles per hour. It's the Offy's 14th win in 18 years. Total dominance, absolute supremacy, and the beginning of the end. That same month, across the Atlantic, a Scottish engineer named Colin Chapman was designing a car that would change everything. Chapman's Lotus 38 used a Ford V8 mounted behind the driver, a rear-engine configuration that had been gaining ground in Formula One but remained almost unthinkable at Indianapolis. American racing tradition held that engines belonged in front, weight distributed conventionally, power delivered to the rear wheels through a long drive shaft. Chapman didn't care about tradition, he cared about physics. A rear engine layout lowered the center of gravity, improved weight distribution, and allowed aerodynamic bodywork that would have been impossible around a front-mounted engine. When Jim Clark qualified the Lotus 38 on pole position for the 1965 Indianapolis 500, the old guard realized their world was changing. Clark led much of that race before a late mechanical failure. But the message was clear. The front-engine roadster, the platform that had defined Indianapolis since the 1950s, was obsolete. By 1966, rear-engine cars dominated qualifying. By '68, the last competitive front-engine roadster had retired. The Offenhauser engine, designed to live in the nose of a traditional roadster, suddenly needed a new home. The Offy adapted, but the adaptation came with compromises. Rear-engine cars demanded lighter, more compact power plants. The Offy, with its cast-iron block and substantial dimensions, was designed for an era when weight wasn't the critical factor. Engineers worked to lighten the engine, but there were limits to how much you could remove before sacrificing the very durability that made the Offy successful. Worse, the new generation of Formula One-derived engines flooding into Indianapolis were purpose-built for rear-engine chassis. The Ford Cosworth DFX, turbocharged and optimized for the new packaging constraints, made power in ways the Offy couldn't easily match. These newer engines used exotic materials, advanced turbocharging, and electronic fuel management that was just becoming practical in the early 70s. Fred Offenhauser had retired. Dale Drake continued running the company, but the engineering challenges were multiplying faster than solutions appeared. The Offy's twin-cam design, once cutting-edge, was now just one option among many. Its four-cylinder configuration, once perfectly adequate, now seemed limited compared to V8s that could package more displacement in less space. Rule changes accelerated the shift. The USAC sanctioning body, trying to maintain competitive balance and control speeds, imposed increasingly complex regulations around boost pressure, fuel consumption, and engine displacement. These rules often favored newer, more efficient designs over the Offy's brute force approach. What had once been the Offy's strength, its simple robustness, became a liability in an era of sophisticated engine management. The economic model was breaking too. Offenhauser and Drake had built their business on selling engines to privateer teams, independent operations that bought power and competed against better-funded factory efforts. But as Indianapolis became more professional and more expensive, those privateer teams struggled. Factory-backed operations with turbocharged Cosworths had resources that backyard Offy runners couldn't match. By the early 70s, the Offy was fighting on multiple fronts: aerodynamic disadvantages from the rear engine revolution, power deficits from turbocharged competitors, and economic pressure from teams that could afford more sophisticated equipment. The engine that had once democratized Indianapolis speed was becoming a symbol of an era ending. Yet, the Offy kept winning, sporadically but significantly. Johnny Rutherford's 1974 and 76 victories proved the engine still had teeth. These weren't nostalgia wins. They were legitimate performances against modern competition. But everyone knew the clock was running out. The question facing the Offy supporters wasn't whether the engine could still win. It was whether the racing world would let it. Could an engine born in the Depression have survived if the rules hadn't changed? If rear-engine cars hadn't arrived? If turbocharging hadn't become the standard? The answer might have been yes, but history doesn't deal in hypotheticals. It only records what happened. May 1977, Indianapolis Motor Speedway. For the first time since the Great Depression, no Offenhauser engine qualified for the front row. A.J. Foyt, the last Offy loyalist among top-tier teams, struggled to crack the top 10 in qualifying. The cars that dominated practice and qualifying were all running turbocharged Cosworth V8s. The sound of Indianapolis, that distinctive four-cylinder howl, was fading from the front of the grid. The racing press treated it with surprising sentimentality. Auto Week ran features about the Offy's glory years, interviews with mechanics who'd built and tuned them for decades. According to contemporary reports, many longtime Indianapolis observers felt genuine sadness watching the engine's decline. This wasn't just another obsolete racing design. It was the end of a thread connecting modern Indianapolis to the track's golden age. Drivers who'd won with Offenhauser power spoke carefully, respectfully. They acknowledged the engine's limitations but emphasized its character. The Offy had a particular power delivery, a linear pull that rewarded smooth inputs. Turbocharged engines hit hard, almost violently, when the boost came on. The Offy built power progressively, requiring different throttle technique but rewarding precision. Team owners faced brutal mathematics. An Offy cost less to purchase and maintain than a Cosworth, sometimes significantly less. But the performance gap had grown too wide to bridge with tuning or driving skill. In racing, speed conquers nostalgia. By 1978, only one or two teams still campaigned Offys at Indianapolis, and those teams were solidly mid-pack, hoping for reliability to move them up when faster cars failed. The engine's manufacturer faced equally difficult choices. Drake Engineering, the company Dale Drake had built around Offy production and support, needed to diversify or die. They began building Cosworth engines under license, maintaining the machining expertise and precision work that had defined their reputation, but applying it to newer designs. The transition was practical but melancholy. The old guard literally building the engines that had displaced them. Collectors and vintage racing enthusiasts immediately recognized the Offy's historical significance. According to period publications, used Offenhauser engines began appreciating in value almost as soon as they left competitive service. Racers who'd campaigned them carefully stored the engines they'd run, sensing that future generations would value these machines beyond their functional utility. Some technical innovations from the Offy's late development found applications elsewhere. The combustion chamber design influenced later four-valve heads. The metallurgical lessons learned from decades of sustained high RPM operation informed bearing and valve train development across motorsport. Knowledge rarely disappears entirely. It flows into new channels. The final competitive Offy appearances came in sprint car racing, where the engine's lower cost and proven durability remained advantages. Throughout the 80s and into the 90s, you could still hear Offenhauser engines at short tracks and dirt ovals, maintained by mechanics who'd learned the engine decades earlier and passed that knowledge to younger builders. This grassroots racing kept the Offy's mechanical traditions alive long after Indianapolis moved on. Public perception split along generational lines. Older fans mourned the Offy's decline as loss of character, the homogenization of Indianapolis into just another international racing venue. Younger fans saw it as inevitable progress, the march of technology that makes motorsport faster and more sophisticated. Both views contain truth. The engine's displacement from Indianapolis highlighted a broader shift in American motorsport. The Offy represented indigenous American racing engineering developed specifically for American tracks by American builders. The turbocharged Cosworths were international designs proven in Formula One, backed by global manufacturers. Indianapolis was opening to the world for better and worse. Industry analysts noted the economic implications. The Offy's decline meant fewer independent engine builders could compete at the sport's highest level. Racing was becoming more corporate, more professional, more expensive. The privateer spirit that defined Indianapolis for decades was giving way to manufacturer-backed teams with budgets the old Offy runners couldn't imagine. But history has a habit of rediscovering what it once discarded, and the Offenhauser story was far from over. By the early 2000s, something unexpected happened. The Offenhauser engine, dormant in garages and museums for decades, was roaring back to life. Not at Indianapolis, but on historic racing circuits worldwide, where vintage enthusiasts were paying extraordinary sums for authentic Offy-powered race cars. A restored 1950s Roadster with an original Offenhauser could command $500,000 or more at auction. The engines themselves, properly documented and historically significant, were selling for $50,000 to $75,000. Sometimes higher for examples with proven racing provenance. The market wasn't just valuing the machines, it was valuing the connection to an era of racing many considered more authentic, more mechanical, more human-scaled than modern motorsport. This collector interest sparked a renaissance in Offy. Rebuilding expertise. Specialized shops emerged, staffed by mechanics who'd worked on these engines during their competitive years or learned from those who had. These builders were maintaining knowledge that could have easily disappeared, documenting tolerances and techniques that existed only in the institutional memory of aging craftsmen. Modern engine designers studied the Offy's architecture with renewed respect. The hemispherical combustion chamber design, dismissed as old-fashioned during the 70s, was being reconsidered for efficiency and emissions characteristics. According to engineering analyses published in the 2000s, the Offy's combustion chamber promoted thorough burning and reduced unburned hydrocarbons, principles relevant to contemporary emissions challenges. The durability lessons proved even more relevant as manufacturers pushed towards smaller displacement, higher specific output engines in the 2010s and 20s. They confronted thermal and mechanical challenges the Offy's designers had solved 80 years earlier. Sustained high RPM operation demands precise oil control, robust bearing design, and thermal management, exactly the areas where Offenhauser and Drake had excelled. Historic racing series embraced Offy-powered cars as marquee attractions. Events like the Monterey Motorsports Reunion and Goodwood Revival featured these machines prominently, their distinctive sound drawing crowds who'd never heard an Offenhauser during its competitive prime. The engine's howl, once common at tracks across America, became exotic and precious, a visceral connection to racing history. Documentary filmmakers and motorsport journalists rediscovered the Offy story. The narrative was irresistible, an engine designed during the Depression, dominating America's most important race for 40 years, then gradually displaced by technological progress but never quite forgotten. It embodied themes of American ingenuity, underdog persistence, and the inevitable march of change. Younger engineers, particularly those interested in vintage racing or historic preservation, sought out remaining Offy experts to learn hands-on skills. Building an Offenhauser required traditional machining techniques, precision measurement with mechanical gauges, and understanding of metallurgy that predated computer analysis. This knowledge transfer ensured that Offy expertise would survive into the 21st century. The engine influenced unexpected areas. Vintage aircraft restorers discovered that Offy crankshafts, modified appropriately, worked brilliantly in certain rare aircraft engines. Hot rod builders valued Offy cylinder heads for their efficient breathing. The component designs proven across millions of racing miles found new applications decades after their intended purpose ended. Some enthusiasts went further, creating completely new Offenhauser engines using modern manufacturing techniques but classic design principles. CNC machining allowed precision that Fred Offenhauser could only dream of. Modern metallurgy provided strength and heat resistance impossible in the 30s. These neo-Offys represented an interesting question. If you rebuilt the engine with 21st century technology, what would it be capable of? Perhaps most significantly, the Offy became shorthand for a certain approach to engineering, prioritizing durability and maintainability over peak performance, designing for evolution rather than revolution, valuing what works over what's trendy. These principles resonated in an era of increasingly complex, fragile technology. The contrast with modern racing engines was stark. Contemporary Indianapolis power plants were technological marvels, electronically controlled, impossibly complex, producing spectacular horsepower. But they were also disposable, rebuilt after every race, maintained by specialists with laptop computers. The Offy had been different, understandable, maintainable, personal. What the Offenhauser represented transcended its technical specifications. It was about craftsmanship, about knowledge passed hand to hand, about racing before corporate branding dominated every surface. The sound of that engine wasn't just horsepower, it was defiance cast in aluminum. What began as an experiment became a legend long after the factories went quiet. May 1950. Bill Holland crosses the finish line. May 1976. Johnny Rutherford does the same. Between those moments, an engine designed in Depression-era Los Angeles redefined what dominance meant in American motorsport. The Offenhauser didn't succeed because it was the most powerful engine ever built. It wasn't. It didn't win because it represented revolutionary technology. It didn't. The Offy dominated Indianapolis for 4 decades because Fred Offenhauser and Dale Drake understood something more fundamental than peak horsepower or cutting-edge design. They understood that racing, at its core, is about finishing, about surviving 500 miles of sustained violence, about mechanical sympathy and thermal management, and valve train stability, about giving privateer teams a realistic chance to compete against better-funded rivals. The Offy delivered all of this, year after year, evolution after evolution. The engine's displacement from Indianapolis was inevitable. Technology advances, racing changes, the rear engine revolution, and turbocharged competition created challenges the Offy's architecture couldn't fully overcome. But the 40-year reign from 1935 to 76 remains unmatched in motorsport history. No other engine has dominated a single venue that long. What makes the story remarkable isn't just the winning, it's the democratization. The Offy allowed mechanics and drivers without factory backing to compete at the highest level. It created a racing culture where knowledge mattered more than budgets, where understanding your engine could overcome equipment advantages. That culture shaped American motorsport for generations. Today, when you hear an Offenhauser at a vintage racing event, you're not just hearing an old engine, you're hearing the sound of an era when racing was more accessible, more mechanical, more human-scaled. You're hearing the accumulated wisdom of thousands of mechanics who learned these engines by hand. You're hearing persistence, adaptation, and engineering discipline that spanned 6 decades. The Offy proved that the best engineering isn't always the most exotic. Sometimes it's the most thoughtful, the most practical, the most sustainable. Fred Offenhauser created an engine that could be built, maintained, and continuously improved by people without unlimited resources. That's a different kind of genius than raw performance, but perhaps a more important one. If you've ever driven or seen one of these machines or heard that distinctive 4-cylinder scream, share your story in the comments. The Offenhauser's legacy lives in the memories and experiences of the people who knew it. Thanks for watching, and I'll see you in the next video.